Engineering 305, homework problem 731. I think I should do an example problem for you. If I've already done one, I think we should do another. And this is from the homework, so this should help you out a little bit, advance you towards your cause. Problem 31. A beam is loaded and supported as shown in the figure. Use the coordinate axes shown, so they've got X and Y. And I can write it on there. Yeah. So now you're seeing the miracle of television. There's my X, there's my Y. They want us to write equations for the shear force and the bending moment for any section of the beam. And I think where this can be problematic because there are three distinct sections. We need to write three equations for the shear, and we need to write three equations for the moment. So that may cause some challenges with this problem, but let's bang it out. So the first thing to do is to find all of our reaction forces, and so let's take a stab at that. I'm going to start with some of the moments about the origin are equal to 0 are equal to, well, the first thing I've got is the 2,000 pound force 4 feet away. So that's going to give me a negative. That's going to give me a rotation from Y to X. So that's minus 2,000 times 4, and this is in foot pounds. And then I've got, well, it's a minus, and this gets really big, minus 5,000, and then the distance is 8, and the units are foot pounds. And then I've got a reaction force at B, right? That would have, I'd have reaction forces there and there. The reaction force at B, and that distance is 12 feet, and that's going to be in the positive direction, and that's going to be in feet, and so RB is going to be in pounds to get me to foot pounds. Take care of all this. So this is a minus 8,000. This is a minus 40,000. Put a comma there so I can tell. And then that's, there you go. So I'll rearrange this all, and I have RB is equal to a minus 48,000 divided by 12. And I'll put the units there, foot pounds divided by feet. And so that's going to give me 4,000 pounds. Realistically, I should... Some of the forces in the Y are equal to RA plus RB minus 2,000 minus 5,000. Oh, but I already know RB, so that's going to be 4,000. So RA, out of all that, RA is equal to 4 minus 3,000. Put that right under my picture. It's good. We should get rid of that picture. All right, so now I have what I need, and I have a free body diagram that now looks like, there's my, and this is 3,000, and this is 2,000, and this is 5,000, and this is 4,000. All right, there's my free body diagram. So then this is section A, this is section B, and this is section C. So if I have my beam and I cut it A, and I cut it anywhere in A, then the only force that I have acting is 3,000 pounds. And that's true for any place on A. So that means that this force, VR, well, I should go through it with the exact same rigor. Sum of the forces in the y direction are equal to 0, are equal to 3,000 plus, 3,000 minus VR equal to 0. So for this section from A to B, VR is equal to 3,000. Sorry, not for section A to B. For section A, which goes from 0 up to 4 feet. Do I need units on 0 feet? Do I need units on 0? It's a question for Professor Hune. So there is the answer for part A. Okay, let's keep going. Here's section A. I start section B. And now I make my cut. And so I have a 3,000 pound force here, a 2,000 pound force here. So I write, oh, and I've got my reaction force, VR. So the sum of the forces in the y direction are equal to 0, are equal to plus 3,000 minus 2,000 minus the reaction force. VR is equal to, well, it's 1,000. VR is equal to 1,000. I am a little bit off in the head yet tonight. VR is equal to 1,000 pounds. Now, that's true. Sorry, I should have put that because that's only for section B, which is now 4 feet x 8 feet, anywhere in those bounds. And that is also just as much a part of my answer as the rest of it. I got to keep going. I got one more section to do. And this is A, B, and here I'm into C. So this is 3,000, 2,000, 5,000. Sum of the forces in the y direction equal to 0 are equal to 3,000 minus 2,000. Oh, minus, it's not plus, minus 5,000 minus VR, because I always draw it right. VR always drawn on like that. That's always my VR. So this gives me a minus 4,000 minus VR equal to 0. VR is equal to minus 4,000. Okay, that's true for a range 8 feet x 12 feet x anywhere in that range. There's the third part of my answer. So now if you want my full answer just for the shear, if you want the complete answer, then what you're going to get is VR is equal to, and a lot of times we'll put these brackets, and I got to go back because honestly, oh yeah, I do remember. It's 3,000 from 0 feet up to 4 feet. It's 1,000 from 4 feet x up to 8 feet. And it's minus 4,000 from 8 feet to 12 feet. Now, The other thing that's okay, it's not cool. It's not. But the other thing you can do with all this information is you can plot VR as a function of X. And what you're going to get is, I start out on the side. Here's my reaction force. I'm going to give you a different color. I'm going to go with rainbows. Rainbows like this. You're going to get this is the reaction force. So this is 3,000. And it goes across to the 4-foot mark, where now I have a 2,000 pound downward. So that's going to drop us to there. That's equal to 1,000. And that runs across till I hit the 5,000. I go down 5. That gets me to minus 4,000. And then I cut across, and what's the last reaction force? It's 4,000 pounds. That takes me back up, obviously, to 0. And that's because when I start and when I finish, that beam can't have any shear in it because there's nothing off the end. If I go back and look at my picture, or I just pull it up like that, there's nothing on the end to constrain that, to give it to do a shear reaction for an equal and opposite. So it has to go to 0. So if your shear diagram doesn't look like that, I guess I could get rid of that little piece here. If your shear diagram doesn't look like that, where it starts and ends at 0, it's probably not correct. It is probably not correct. And so this gives me a really good picture of what that answer is just for the shear. Now we need to go back and do that for the moment. All right? Zoom. But I've got all my reaction forces, so I got to redraw my beam. Bummer. Beam looks like this. 3,000. 2,000. 5,000. 4,000. Section A, I split it there. That gives me a diagram that looks like this. 3,000. I got a split there. I do have, technically, I do have a VR, but remember, that is that shear force. But since I'm going to do my moments, I'm going to sum my moments about that point. The VR doesn't matter. So it's there, but it's not there. And then I need to include, that's not right. That's not right. That would make a unhappy face. I want MR. That's shown in the positive direction. That makes a happy face. So MR is positive. And that's all I've got. So now it's some of the moments about the cut are equal to, well, it's 3,000 times whatever distance I have to go. 3,000 times this distance to the cut. 3,000 times that distance to the cut. That's the moment from that force. And then I don't have any other forces. I just have that reaction force. So that's going to be, oh, you know what? This is negative. That's negative. That's going to cause it to go from Y to X. So that's negative. And then MR is a positive moment. Okay, and that's all equal to 0. Should have put the 0 in there first. So MR is equal to 3,000 X, and the units are foot-pounds. All right. Let's keep going. Next section. I got my cut there. A. I'm into section B. I'm not going to draw it. Well, okay, I just said I'm not going to draw it, but I'm drawing it. I've got VR. I got MR. I've got 2,000. 2,000. I've got 3,000 pounds. Pounds. Sum of the moments about the cut at B, if I want to put that. I don't want to put that, but I did. Is equal to, well, here's the thing. The moments that this contributes to this are exactly the same as they were up here. It's just a longer x, but that's still correct. So it's minus 3,000 times x. Now I've added in this additional term. That's going in the other way. That's actually going to make this rotate from x to y, so that's a positive. So that's a plus 2,000. But now my distance is not x, it's x minus, that distance is 4. And so it's x minus 4. And those are in the right units. I should be, I'm not. And then I've got a plus mr. And so, well, I just have to multiply that all out. So that's kind of, if I do, well, honestly, my brain's too tired to do this well, so I have to do it very carefully. MR, I'm going to move that to the other side, is equal to, it's now a positive 3,000x. See how I almost messed that up? And then I'm going to write this out carefully. Minus 2,000x, because it was plus, so it goes to minus. And then it's going to be a 2,000 times a negative 4 to give me a negative. So that's going to become a positive. So that's going to be plus 8,000. And so this is, it's minus 8,000, so it becomes plus 8,000. So this becomes 1,000x plus 800, plus 8,000. And that foot pounds. All right, and I've got one more section to do. Which is yeah, C. I have a feeling you guys watching this are just going, wow, he was really sharp at the beginning of this, but his brain's fading and he's just not doing it. Okay, you might be right. Might be. 3,000, 2,000, 5,000, MR. Some of the moments, see, I almost wrote some of the forces. Some of the moments about the cut equal to 0, equal to 3,000, but I got the sign wrong. It's negative 3,000 times the distance x plus 2,000, because that's going to be a positive, and that's going to be a x minus 4. Wherever it's, again, it's the same, because the cut just moved. It doesn't mean that changed the equation. My distance just grew. So x minus 4 plus 5,000 times x minus 8, because that's where this is now, 8 feet. So the distance from the cut to that is x minus the 8. And then I got to put on, I'm going to slide this over just to give me a little space, plus an MR. So now I'm going to rewrite this MR Why did you guys let me change sign? Oh, yeah. Sorry. Sorry, just a little issue there. MR. And now I'm going to collect all this stuff. So it's a minus plus 3, and I'll write out the zeros. I was going to skip the zeros. Minus 2,000 minus 5,000 all times x, right? Plus an 8,000 plus a 40,000. Because that's this term, get me a color, this term comes from there, and that term comes from there, where this term comes from there, and this term comes from there, and that term, you got that. All right. Equals minus 4,000x plus 48,000. And I should have been putting in the ranges. This is for 0x to 4. This is for 4x to 8. Really, I'm just going to rewrite this all right here. So moments are equal to, let's go back up. For the first section, it's this one here, 0x 4. Here's the first equation, 3,000x and that's for 0 to 4 feet. And then the second equation was 1,000x plus 8,000. And that was from 4 feet to 8 feet. And then the last equation is minus 4,000x plus 48,000. And that goes from 8 feet to 12 feet. Now, let's plot this the same way. My moments, I'm going to give myself a little more space. And maybe I should, you know, this is going to be positives and negatives. It's actually going to be mostly negative. It's 3,000 times x, and so if I go out, let's go 3 squares per. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 3,000 times x, it goes out to, that would be 12,000. So I'm going to only do half of that. I'm going to only go up 6 squares because this actually is going to go down to, that's going to go way too big. I'm going to actually divide by 6, honestly. So 3,000 is only going to go up 2 squares. So from 0 to 4, and this is now I can do better than that. Sorry. I can do 4 squares. 1, 2, 3, 4. So it's 3,000 per. That's 12K. And then, okay, so that's true for that. So then, what happens now here at this point? At x equal to 4, this is 4,000 plus 8,000, so that goes to 12,000. Oh, that's good. So it starts there. Accident? I think not. It goes to 12,000, and then it keeps rising. Oh, maybe I made my whole plot wrong. Oh, this is going to be really terrible. It's going to go up over the next 4 feet. It's going to go up another 4,000 to 12,000. And it's going to go up over the next 4 feet. So it's going to keep rising because that's my slope. At 4 feet, it's 4,000 plus 8,000. At 8 feet, it's 8,000 plus 8,000 to get me to 16,000. So if that was 4, they're 3 each, so I got to go just a little bit above that. In other words, this has a slope that has a slope of 3,000, and this has a slope of 1,000. So yeah, it looks kind of right. And this value is now 16,000. 16K. So, okay, so let's figure out this last one. At 8 feet, it's equal to negative 32,000 plus 48. That'd be 16,000. Right there, right at the end of the last line. So this is continuous from the left and from the right. The slope is not continuous, but the value is continuous. And then where does this go at the end? Well, I've already told you that we should go back to 0. I don't have anything on the end to give me a moment. So what's the value at 12? At 12, it's going to be minus 4,000 times 12. So negative 48,000 plus 48,000. So there you go. So this slope is minus 4,000, but it gets me back to 0. And that's what the beam should do. So that's cool. Oh, I want to get rid of that, don't I? Sorry, I want to get rid of that. I hope that didn't mess you up too much. That's cool. So I've got my, so if I zoom way out and look at what I did, I've got a solution here, and I got a plot, and then I also did that up here for the shear. So it's all good. It's all done. I hope that makes sense. It might be, yeah. I don't know if another example would help you or not. Maybe you should fill that in the comments below. That's what I see when YouTubers, right? Fill it in the comments. All right. I hope you guys have fun with this. These do become easier and easier and easier the more experience you get, but that means you got to have more experience, which means more homework. But there are some tips and tricks that I'm not telling you that will come out later that will make this easier. So anyway, hope you're doing well. See you later. Don't worry, there's more to come.